You so much, Sophia. All right, it's my absolute pleasure to be here today and present to you my topic, data quality assurance in credit card fraud prevention. Oh, why is it not? I tested when I was in the room. Okay. Oh, okay, that works. A bit more details about me, so you get the context of why I'm talking about data quality, why I'm talking about fraud detection to you today. I work as a senior fraud analyst at Klarna, and how many people have heard of Klarna? Great. I'm very glad to see that because 2 years ago, when I started working for Klarna, 90% of people I encounter have never heard of Klarna. But now, with all these marketing campaigns with the celebrities, for example, Paris Hilton or Snoop Dogg, maybe more and more people have heard of it. What do we do actually? So, we are a payments company that specializes in buy now, pay later. And what that means is if you go on Macy's.com or Sephora, and when you check out, you have an option to pay with Klarna in full. And you can get your items now and pay in the subsequent periods of times. So basically a financial product. And why I got so passionate about data quality. Initially, I got lured into data because of all these buzzwords, machine learning, big data, use data to tell stories. These are all the fun parts. However, over the years, as I work on generating insights and use data to draw a conclusion, I realized if you have bad data quality, then there's a famous saying, junk in, junk out. So data quality is important. And besides work, I'm also interested in playing board games, especially social deduction games. And how is that relevant to my work? That's because these social deduction games are like playing detectives. You detect bad guys from the good team. Anyone played Mafia before? And that's very similar to what I do at work. I use data to catch the fraudsters, the money launderers. And I also do Toastmasters. And any Toastmasters members here? Oh, Phil is. That's why you're so good at public speaking. You gave that opening this morning. All right. More about the actual topic. What I'm going to share with you today are, first of all, why should we care about data quality? Why should we care about data quality in credit card fraud detection? Second, what kind of data quality problems will we encounter at this field? And thirdly, how do we solve these problems? How do we deal with these challenges? Well, first of all, why should we care about it? Do you know that in 2023 alone, in the US market, there is $10 billion credit card losses due to frauds. And that is equivalent to 150,000 US households' annual spending. That's the money we could have sent our kids to school, could have bought another game ticket, or could have bought another car. And all these money are still stolen by the fraudsters. So this is how large the scale of problem is. And if we want to tackle this problem, how do we do it? And that relies heavily on the data. like I mentioned before, we are just like Sherlock Holmes, but working online, not at the crime scene. But it's very similar. Every piece of data we get is like an a piece of evidence that we can put together to solve the case. And we mainly use behavioral analysis, fraud, and we use data to detect fraud attacks. And we also use data to conduct investigations. This is an example of how frauds are conducted usually. This type of pattern is called impersonation. And we start with a genuine customer. They do have a Klarna account. And the fraudster will hack into their account, then go on a shopping spree, buy 10 pairs of Nike shoes, and ship it to their address. Now the real customer is liable for the credit card debt. How infuriating it is. And given this scheme, what kind of data can we collect? If you were me, if you are an investigator, where would you start with? Yes, please.
Like where the product is shipped to?
Exactly. That's a great answer. And how does that tell us the story?
Well, the customer has an address on file that's, say, here at Portland.
Mm-hmm.
Merchandise is shipped to Hawaii. Maybe it could be a signal that there's fraud. Maybe not.
Yeah, could be my aunt.
I think also what they're buying.
Mm.
Different vendors or stores are different than they usually go to.
Could you give a more detailed example?
Well, I go shopping at REI a lot, and but if somebody had some other outdoor store like Dick's Sporting Goods and they charge a lot to Dick's, then that's obviously not me.
Yep, great answer. Spruce?
And also quantity, so if you usually only buy one pair of shoes, you only buy like once a year or whatever, and suddenly buy 10, that's a red flag, it could be a red flag.
Yes, exactly. There could be cases where I have 10 nephews, but it rarely happens.
Login location.
Login location, great. Yeah, that's a very important one. Thank you all for the answers. You all got points because you'll see in this slide, I will show a lot of data points that we can use to solve the case. First of all, the personal information of the customer, and that includes first name, last name. Oftentimes we use our names or abbreviations, initials in our email addresses, right? So if I'm Yuqing Yao, I'll use YY0903, and I wouldn't use Phil 2005, for example, as my email address. And from an event, log in through different devices. Shopping behavior, like what Phil said, if I shop at REI and now I all of a sudden stopped shopping there and started buying stuff at Gucci. Customer info, shipping address, this gentleman answered. And we also use payment behaviors. Did the customer all of a sudden stop paying back? And that could be an indicator something happened to this account. And after understanding the types of data we use, we can deduce the types of problems we encounter because each kind of data will introduce different types of problems. For example, for front-end events, sometimes our systems just don't capture that information. We don't always get the device ID. For example, Apple sometimes will cause more problems because they have a stricter data sharing standard. And our disputes data is how we label whether it's fraud or non-fraud. If the customer disputes and say, oh, I didn't make this transaction, we use it kind of as a source of truth to label this transaction as fraud. But what happens is the frauds are a very small percentage in our data set. Usually 0.5% to 1% are fraud, which is good for the business, but it makes data crunching or building models harder because it creates that class imbalance problem. And disputes are also oftentimes reported by the customer, or they call our agents and the agents will log that information. It's oftentimes manual. When human element is in the loop, there are errors introduced. It's you just have that data entry errors. Besides the type of problems based on the type of data, we can also think of problems from the workflow perspective. Each step, when we process the data and when we use the data, that's a step that we can make mistakes and introduce data issues. So here's an overview of the workflow, the tools we use in the whole fraud detection process. We start from data sources. We collect either from our front-end events or our vendors. And then we ingest the data either through streaming or some batch processing. And then we store the data for future usage. We can use warehouse, data lake, or in our case, it's a data lake house. And then you do visualization or modeling. And last but not the least, it's actually the most important part, is using all these insights to generate pattern recognition and either reject or accept a transaction or a credit card application. So based on this data stack, we can understand at data ingestion, sorry, there's some noise. At the data ingestion step, we can have latency. And when we do batch processing, we can introduce wrong calculations. We just coded the formula wrong. And when we store the data, if we are not careful, we can create data silos. And the third way to think of data problems is through the nature of the task. First of all, I think just like other quality assurance functions, we are not revenue generating. So it's at the cost center. Usually it's an afterthought of the business. The executives know our existence, but they wouldn't constantly check in with us. We keep the lights on most of the time, 99.5% of the time. They don't need to actively pour more resources to us. But when that 0.5% of the time fraud attacks happen, then the executives will realize how important this function is. So that create some challenges for us to upgrade our systems or acquire or hire talents who have good data practices and have good intuition to solve data problems. And secondly, I think just the nature of the task itself, it's not the most fun type of work out there. Finding data problems and solving data problems. There is no such major in college. It's called data quality assurance, but it's needed in the industry. So sorry. So my point is, once your brain gets tired of something, you'll start to make mistakes. And that's another source of how errors are introduced. Recap on the types of data problems. First of all, by nature of the data, we have imbalanced data because fraud is a small minority. And we can have wrong labels. You categorize a non-fraud transaction as a fraudulent transaction. And thirdly, incomplete data just because we didn't get to capture the data points. By procedure, we can have latency in our systems. And we can have wrong calculations or data silos. And thirdly, by the nature of the task, because it's not the priority, it gets less attention. And it could be tedious to do. And that creates problems, that creates errors too. Now we know what are the problems and how do we solve them. We can take a look at the tools we have. This is a map that I created based on the solutions in the industry out there, attended data conferences and collected the information, like what vendors are out there for each step in the data processing. When we lack of data, we can use data enrichment services. And there's also entity resolution solutions that help solve duplicate entity problems. When we ingest the data, we can set up automated monitoring, have the checks and balances in place. So when the values go out of range, it could send alerts. For data storage, it's important for us to have a good data catalog. And that tells us when we have two very similar tables, mailing address and billing address may mean very similar things. And are they actually the same? We need data catalog to tell us that answer. And data catalogs also tell us the lineage of data. Sometimes an upstream table and downstream table share a big set of data, but they are named differently. Yes.
Give some scale, like how much data you're dealing with, how many customer accounts? Is there a reason to use specialized tools, as opposed to general purpose tools? You know, because it's hard to visualize just how much data you have to do.
So that number, I don't have that in mind. But the reason we use specialized, well, these are may apply to other domains too. For example, e-commerce. But the setup of having like a decision engine or having models may be different. But to your question, yes, a lot of times we can use the same set of tools. But for each tool, their configurations could be different. And specifically, entity resolution is for them, fraud detection is a very big use case compared to other domains.
I mean, do you have like tens of thousands of user accounts or millions of user accounts? What?
Millions.
Millions.
Okay. I think the map is kind of overwhelming and it's a lot of information. So I'm going to use 3 anecdotal examples to show you how exactly we find problems. Why are these problems problematic? And how do we use tools to solve them? The first example is about wrong labels. And what is the problem here? We have the dispute reason being null, even though we know there is a dispute from the customer. So why did the customer dispute? Is it because they got the wrong merchandise, or they found out they didn't make that transaction at all? It's actually someone who hacked their account and made the transaction on their behalf. The first case, it shouldn't be fraud. And in the second case, in the second scenario, we should categorize it as fraud. And the problem it causes in our analysis is usually for supervised learning. For fraud versus non-fraud, it's like a classification problem, and there are different ways to tackle this problem. Here's an example. If we use supervised learning models, there is one specific point. Let's say it's this customer, John Smith, and we just miscategorized their dispute as non-fraud, then our decision boundary will be here. And if we feed new data into this model, then if they land in this area above the orange line, they'll all be categorized as fraud. But if we correctly categorize this customer's dispute as fraud, then this blue dot will turn into red dot. And when we train the model, the decision boundary will just change. And this is a larger area where if the dot lands in this zone, then they'll be categorized as fraud. So even just a few data points can change your model. And take it into context of our workflow. What exactly caused this problem? And in our case, it's the agent, when they close the case, there's an input field called dispute reason. It's text input. So you can put whatever you want. And typing in is a lot of work, you know? So what ends up happening is the agent just doesn't type anything in, and we have those missing data points. How do we solve this problem? We can just change the UI and turn it into a drop-down box. And now we have embedded data validation that makes data input mandatory, and it's more standardized. As a result, we have a higher rate of data points being populated and more standardized values. The second example is for abnormal values. In fraud detection, oftentimes frauds are anomalies. However, wrong values could also be anomalies. So if both of these things happen, how can we tell if they're actually frauds or they're just wrong data points? A more concrete example is all of a sudden, if we see a lot of 9999 in our data set, what has happened? Any guesses?
About data type?
Close. Sorry. What? Good guess.
Data mapping.
Yes, that's the reason. So sometimes when there is missing data, we'll fill the missing data in different ways. You can fill it with zeros. You can fill it with NA. You can fill it with a very high value. There are certain scenarios, it's preferred if you map it to very high values during the decision making. But in this case, it is they just chose to fill it with 9999 without telling the downstream team. I know it sounds absurd, but it happens. And sometimes it happens to data vendors too. They just change the configuration and we find out through our process being broken. And what kind of problem does it cause in our analysis? So again, we use models as example. Besides supervised learning, we can also use unsupervised learning, which includes clustering. Basically, we assess how close or how similar these data points are, and then group them as different classes. So if we have all these 9999s, the 9999s will be grouped together. And all the other data points, because they're just so close together, they will be grouped into one class. However, if we get rid of those 9999s, now the data got spread out. And if we run the algorithm again, these two data points will be grouped into the same group and the rest the other group. So we can see that these extreme values, they're data errors, and they cause our model training to have very different outcomes. And like I mentioned, it could be just the vendor changed the definition without notifying us, or it could be the upstream team changed their data mapping. And how do we resolve this? One way is to set up data monitoring, and we have certain rules to check for extreme values. For example, 10% of the values over 2 standard deviations away from the average over the last 1 month. So when this condition is triggered, we can have the monitoring system send us alerts. It can go into your Slack or your text, and that's how we can solve the problems faster.
What does recover do?
Oh, good question. Recover is when the certain conditions are met, you know it ceases to be an emergency. Yeah, for example, in Datadog, you can set up alerts, and when the condition no longer get triggered, it will turn into recover, and it sends you another text. Oh, this is actually recovered, so you don't have to deal with it anymore.
I thought it was like automated recovery, like it would go fix the data.
Oh, that will be nice. Yeah, one day, if our AI is that smart. Okay, so if we have those alerts, and then we can fix the data faster and block the data before it gets to our model environment and contaminate our data training, our model training. The third example is about disconnected data. Okay, what does that mean? So sometimes the customer may create multiple accounts intentionally or unintentionally. John Smith has this account with the js95@gmail.com. And John KP Smith has a different email, but they have the same phone number and address. Are they the same person or no? Or they're just roommates? In that case, we can have other data points that all combined going through certain algorithms and Yeah, and then resolve to the same entity. Okay, going back. Why is that a problem? That's because we can upsample. Well, if it is a fraudster and they committed fraud in our systems, it's two separate records, but they actually should be the same record, and that could artificially create more noise in our training. And besides, sometimes when the real customer is not aware of fraud happening to them, we can still detect it even if it's not reported. However, well, one way to figure out is through linked account. If a lot of accounts are share the same attributes, and it could be a fraudster using legit customers' credentials or identity to create these accounts and go on shopping. So this is a pattern that we could miss out if we fail to link them together. And in our work scenario, what could cause this problem? So first of all, the customer could cause this problem by signing up through different channels or different email addresses. And it could also come from our internal systems, marketing, and the login platform or our vendors all use different set of identifiers, and they have a different set of values about this customer. And if the data sits in silos, then it's hard for us to link them together and realize they're actually the same customer. And the solution is entity resolution. It's a set of algorithms. There are different ways to do it. But through this technique, we can connect these customers and have confidence that they are actually the same person. And as a result, on the left is if we don't connect these customers together and not realizing they're the same person. And on the right is after entity resolution, we connect dots together. And in the graph format, we can detect there is a fraud ring going on. And then we can look into this fraud ring further. As a recap, we looked into 3 different scenarios, 3 different types of data problems, including wrong labels. We resolve it using having data validations and better UI design. The second problem is abnormal values. These are extreme values that could skew our analyses, and we resolve them by setup monitoring and alerts. The third type of problem is disconnected data, where different customers, same customers are identified as different ones digitally. And we resolve it using entity resolution. Okay, for conclusion, we looked into why data quality is important because it has a very large scale of losses. It creates problems for consumers and financial institutions. What caused these problems include the nature of the data, and in each step of our data processing, our analyses, we could introduce different problems as well. And just because of the nature of doing data quality assurance itself could cause some problems. And lastly, how do we resolve these problems? It relies on the tools we use and having a good culture and having that mindset of designing our workflows to detect data issues faster and solve it faster. For future improvement, we looked at anecdotal cases today, and that is partially because we need to be cleared by our communications team if we share any real cases or values to the public. So hopefully in the future, I can get to share some real data. And besides, now everyone is talking about AI, and there are cases, including our firm, using AI to detect data problems or do decision making. And as we introduce new technology, we also introduce problems. How do we do quality assurance for these AI systems? And that's what we can talk about in the future. All right, that concludes my presentation. And there's a QR code for a survey of scoring the presentation, and you can also give me some feedback. I very much welcome feedback. Now I'm open to questions.